yesterday's live, poor network issues, so I couldn't continue the live stream to the end. So guys, like I was saying, the one I made a long time ago, you can say the flywheel. This was the one I made a long time ago, and there are some issues that are developed along the way. There are some things I would need to change, and this is the charging system. Like I said, this is the charging system. We have the alternator. We have the flywheel, which is very heavy, but it looks it's rolling freely because of the ball bearings inside. And we connected this leather right here. Because of misalignment, this leather is connected so that it will help the system to roll very freely, and it would not affect the frame of the generator. So guys, we're using a 12 volt DC motor, and this DC motor, it's very powerful. This is a 1 horsepower DC motor, which we are using to power the system. This is a 2900 watts alternator, and these are the terminals. This was connected to a car battery to power the system for it to work very well. 12 volts, it's okay. You can also use a 24 volt system or a 24 volt DC motor to be able to power the system. I used the first one I made. This was the second. The first one I made, I was using a universal motor. I'm so sorry, the universal motor, it's not here with me. If not, I could have showed you guys. That one both runs on both AC and DC power. For the universal motor, it runs on both AC and DC power to be able to power the system. So I was relying on a universal motor, trying to use a UPS to be able to power it, and for it to generate, spin this alternator, generate current, and in turn should be able to power the UPS back so that the system will be able to charge the battery very nicely. That was what I was trying to do. And remember, this is a 1 horsepower DC motor, and this 1 horsepower DC motor, if you were to convert it into watts, it will be around 750 watts. That is the equivalent of 1 horsepower. So 1 horsepower amps of this DC motor, its amps is equals to wattage divided by the voltage. The voltage of this DC motor is 12 volts. So we would say 750 watts divided by 12 volts will give us around 62 amps. So we would need up to 62 amps to be able to power this DC motor effectively. So powering this, once this DC motor is being powered by the 12 volt battery through these terminals, it spins the alternator. This is a 2900 watts alternator. So once it spins it, there will be the power it's consuming will determine. It's all dependent on the amperage. 62 amps is high, so the discharge or the power that is being consumed, you need to be able to replace that power into the battery. So power being consumed and power being generated, the power being generated needs to be higher than the one you are consuming so that it will be able to charge the battery effectively. So what I'm trying to do is, one thing I notice is that this DC motor is a little bit downsized for this alternator. Remember, this alternator is a 2900 watts alternator. I notice anytime I power the system, this 12 volt is spinning the alternator. It takes up to like 10 seconds. It takes up to like 10 seconds for it to generate electricity, and that is a whole lot of time. that shows that this 1 horsepower is a little bit smaller for this alternator. So for it to be able to spin this alternator and generate current effectively, what I need is to change this into a 1000 watt alternator. That will be able to do the job. Though I would love to leave this setup like this. Later on, I can what I'm going to do is to upgrade this DC motor, and once I upgrade this DC motor, I can upgrade it to a 4 horsepower DC motor, and it will be able to power this efficiently. And you guys can tell this is the charging system. You can see the charging system. So you guys can give me a thumbs up. You can double tap the screen to let me know you're there. So this was the charging system I was using. It has the PC fan in there, which charges the system, which charges the battery through the terminal cables. You can see it through these terminals. So that was what I was relying on, and there are 2 big transformers in there which are connected in series to increase the voltage and the amperage so as to be able to charge the battery. So guys, for the system to work, you have to be able to power this DC motor and generate a whole lot of power to be able to charge the battery, because the rate of discharge and charge must not be equal. The rate at which it's discharging and the rate at which it's charging. The rate at which it's charging is supposed to be higher than the rate at which it's discharging. That's the only way the system will work. So what I'm going to do later on, you can see the frame of this generator. I'm using a wooden frame. I had to start with something so as to get an idea of the whole thing. I had to use a wooden frame for it. You guys can see it. That's wood all around it, wooden frame. This is how the back of the alternator looks like. You guys can see this is the rectifying diode which I was using for part of the charging system, but this rectifying diode can output around 8 amps. 8 amps is too small to be able to charge a car battery of around 75 amp or maybe around 100 amp. It will be too small. Remember, the electric motor, the DC motor is consuming 62 amps. So we need to be able to produce, if not times 2 or times 3 of that amperage, to be able to charge the system effectively. So I connected a capacitor somewhere here. This is where the capacitor line is being connected. The capacitor, I removed it. This is where the capacitor line is being connected. So for these types of alternator, this is a 2900 watts alternator. They use up to you can use up to 30 UF microfarad capacitor to be able to power this system, and it will work effectively. So that is it. So guys, I said there is a delay in the system. Whenever the DC motor is powering the alternator, it takes up to 10 seconds. Sorry. It takes up to 10 seconds for it to be able to generate light, which I don't like. So I'm going to make there's a new generator I'm going to be making. I'm going to be changing the frame to a metal frame. Everything will be bolted down to the frame. I'm going to be using a generator frame for that project, and I'm going to be using a smaller alternator. Though later on I'm going to scale it up, but I feel it's best to start smaller. Then when you get the scope of everything, you start scaling it up. So the alternator I'm going to be using for this system, it's this alternator. Yeah, this is a Tiger Gen alternator. You guys can see it. You can see how free it is. I just coupled it not quite long ago. This is how it looks like. Let's try to turn it the other way. So this one is a 1000 watts alternator. In most cases, you will see it boldly written 950 or 850. So they are not actually 100% 1000 watts alternator. So this one is gotten from this popular generator you guys know. I passed my neighbor, and you can see how free it is. Best for you to make sure that the coupling or the shaft is rolling freely. That is the number one thing you need to put into consideration. If it's very stiff, it won't work the way it's supposed to work. You can see how freely this one is, and the one I did before this one too, also it's free. So my aim is to take this this DC motor, 12 volts. This one can run up to like 3000, I think around 3500 RPM, which is more than enough to be able to power this alternator to be able to produce electricity. This one runs at 3000 RPM, so almost 3500 RPM for it to generate electricity. So what it means, it needs to rotate more than 3500 RPM or tons within a second for it to generate electricity. Without that, if the rotation is a little bit lower, it will not generate electricity. That is how it works. So, but for this one, the delay I'm getting for this, which is 10 seconds for it to generate electricity, I would not be getting it from this. With this one, it will be instant. Whenever you power the DC motor, it should be able to rotate this 1000 watts alternator to generate current quickly. So these alternators, if you take a look at them, originally they come with 6 wires, but this one I have right here is coming with 4 wires. This alternator is an old alternator. I think this alternator was gotten from a generator from around 2003. So you can see this alternator has been with me for a long time. So most of the wires, I think, most of the 2 wires right now are not here. I think they've been disconnected because the wiring the coil got burnt and it was recoiled, and I think the remaining 2 wire was not brought out. These yellow ones you see right here, they are for the capacitor. Why these other 2 wires you are seeing right here, this one is for the output, which is the AC line. It produces up to 220 volts to 250 volts. That is where you can get the output from these 2 lines. So these 2 are for your capacitor. And for the Tiger Gen, which is this 1000 watt alternator, the capacitor that can be connected to this, that came standard from the manufacturer, it's a 24 UF capacitor. 24 UF capacitor, which is 24 microfarad capacitor that comes with this one standard from the factory to be able to give you the output power. Because without the capacitor connected to these 2 terminals right here, it would not produce electricity. Note, without the capacitor, it would not produce electricity. The aim of it producing electricity is because the capacitor is to store part of the current inside, then convert it into 220 volts for it to be able to work. So standard 1000 watt alternator uses 24 microfarad capacitor for it to be able to work. But I'm going to be upgrading it. I'm going up to at least 30 microfarad. 30 microfarad capacitor should be more than enough for this system. I used the last capacitor I used for this one, for this big one, which is 2900 watts. 2900 watts alternator was a 30 UF microfarad. That was what was connected to this one, but I'm still going to use the same thing for this one. One thing you need to notice, it is best not to use more than 30 microfarad capacitor for this 1000 watt alternator. Why? Because if you were to use capacitor that has a higher farad or a higher microfarad on it, it can end up burning the coil. So it is best to use 30 microfarad is still okay. You can go as low as 24 microfarad. So you can see how free the shaft is. So what I'm going to do, I'm going to find a way I can use these shafts. I'm going to find a way to connect it to this 12-volt DC motor, which is 1 horsepower. 1 horsepower should be able to spin this one nicely without any stress. Since there's a delay on these since there's a delay on these 2900 watts alternator. So this alternator, I'm going to keep it with this. I'm going to leave it on this frame because later on I'm going to be upgrading the alternator, the motor, to a 24-volt motor of maybe around 4 horsepower to be able to power the system effectively. So to power this, we're going to start small and scale the system up. So the aim of using this DC motor, it will be able to power this system nicely. So this is how the back of the alternator looks like. So we're going to use this one to start our new project, and we're going to be using an iron frame for the whole system so that it will be strong, it will be rigid, and it's going to work the way we want it to be. And later on we'll be spraying the system also too, and it will work effectively. So for the charging system of this one, we're going to be using, there's a new charging system we're going to be using. We are not going to use this old charging system, though this one has a PC fan in it, and it has the 2 transformer inside which are connected in series to give it higher output voltage. Though we are going to use we might even end up using what is called a DC to DC buck converter. A DC to DC buck converter. With that DC to DC buck converter, you can be able to using high voltage architecture to be able to charge the battery should also work, and we should be able to have a good amperage to be able to charge the battery also too. So guys, that is part of what we're going to be doing. I'm going to be from time to time, I'm going to be showing you guys how the project is going. But first, we'll be mounting this on a big generator frame. You guys know the this fireman generator frame. That's what we're going to be using. We're going to be mounting this one on the frame, and we'll be connecting the 1 horsepower electric motor. So for those who are just joining us, one thing I explained is that this DC motor, I don't know why I keep on calling it electric motor. This DC motor is 12 volts, which is 1 horsepower DC motor. So 1 horsepower DC motor is equivalent in watts. It is equivalent to 750 watts. And for you to be able to find out the amperage of this DC motor, for it to work effectively, is amps is equals to watts divided by voltage. So your watts divided by voltage. The voltage right here is, you can see it boldly written 12 volts. And the watts for this is 750. So 750 divided by your voltage, which is 12 volts, which gives us 62 amps. So we need up to 62 amps to be able to power this DC motor effectively, and we need times 2 of these amps. This is 62 amps. We need times 3 or times 2 of it to be able to charge the battery effectively, and for it to be able to run the system effectively. So you've seen that the rate of discharge or the rate of charging should be higher than the rate of discharge. That's the principle behind it. The rate of charge, which is charging the battery, should be higher than the rate of discharge of the system. That is the only way we can make it work effectively. You can see this one, I connected starting coils to it. The starting coils do generate some electricity at some point because of these. This is a magnet. This black side you're seeing right here, a magnet is connected to this middle. This bolt you see, this side I'm touching right here, this is the magnet. So anytime this magnet passes through this starting coil, it generates some electricity from this terminal right here. There's another one right here. it generates electricity from heat. But I'm not going to be using this because I noticed the electricity being produced from this starting coil, they are higher. I used my multimeter to test it and it blew my multimeter. And the funny part was that the multimeter was set up to 1000 volts. The multimeter was set up to 1000 volts. It ended up blowing it. That is to tell you how powerful they are. But I tried to use a rectifying diode to reduce the voltage which was being produced by these two starting coil, because the two starting coil were connected in series. That is to boost out the output power from it. So, which means the power that is being produced from one of them will be times 2 when they are connected in series, but it ends up blowing the multimeter. So, after using a rectifying diode to reduce the voltage, to convert it from the AC, because anytime I use my hands to touch it, it will shock me. I'll get a shock from it. So, that is to tell you how powerful they are. So, what I did was to use the rectifying diode, connect it to the what is it called, to the starting coil. I noticed the voltage that was produced from it, which was DC voltage, it was high, but it wasn't efficient enough to charge other system. That's why I would not be using the two starting coil for this new project. So this new project will be simplifying everything, making everything as simple as possible. We have to be realistic and we have to be practical while using the DC motor and also the alternator. So everything we are doing right here, we have to make sure the rate of charging the battery of this generator, of this four-phase generator, needs to be higher than the rate of discharge. Remember, we're consuming 62 amp from this, which is around in watts 750 watts, which is equivalent to 1 horsepower. So we need to put that into consideration. You can see that physics do play a big role in the system for it to be able to work efficient. And you need to take note of these shafts. Make sure they are free. These shafts need to be very free while they are working. If the bearings are not okay, it is best to change them so that you would not have an issue with them later on. So it is best to change them. But you can see it's rolling freely. So we're going to find a way to connect the shaft, connect it to the DC motor for it to work effectively. As for this, I don't know if I'll be connecting, I would love to connect a flywheel to it, but I don't know if I'll be connecting a flywheel to it. Let's see as we go. And this fan, I'll still be using this fan. The fan, what it does is to suck air from the this middle side. You see we have about 6 holes on this DC motor. The holes are for air to be able to go inside the DC motor to cool it. So this fan, with the help of this fan, it will suck the heat out from this DC motor, so that, and it will push it out from the side. So it sucks it from here, push it out to the side. So what it does is to cool the DC motor. It is best once it's running cool, and that will also help to play a big part in the efficiency of it while it's working. Do you guys know that each of these alternator, like this big one, which is the 2900 watts alternator, this one has a big fan in there to cool the alternator. So you can see it needs to be cooled down so that while it's working, it will increase the efficiency. Also, this one also has a fan in there too to cool the system too. That's why they do have from the side here, you see the side vents. These are the side vents, and the fan, it's in there to cool the system, because whenever we have moving parts, they tend to generate heat. They tend to generate heat. So those fans are very important for it to work efficiently. So that's why we'll be connecting this one with the fan to make it work very nice. So guys, that is part of the updates I have for now. I'm trying to get, as you guys can see, this alternator is not complete. There's a part of the engine which I'm going to connect at this front right here. There's a part of it, if you see, from this side, you can see the other part which is supposed to be connected to this side here. It's not connected, it's not here. I'm going to try to go to one of these generator repair shop to see if I can get that part. And once we connect it to this side, once we get it to this side, it will help to raise the system to sit down upright. And that is where this ball bearing you're seeing right here now is connected to. It will make the shaft to even be running smooth, to run smoother, to run very smooth. So that's what we're going to do. Can't wait to show you guys the progress when we start making it. I might not be doing the project live, so what I'm going to do is that I'm going to be shooting the video so that everything is going to be clear. I notice in my area I do have problem with what is it called, with network. So I'm just trying to see what I can make do with the network I have around here. So guys, we'll just be keeping this alternator, this big one. You can see the rectifying diode, and these are the AC line which will be connected to our light bulb. So you guys remember that this rectifying diode produce up to 8 amps. So 8 amps would not be enough to be able to charge our battery. So we would need to use a different charging system. There are other ways for you to do it. You can use this rectifying diode connected to a boost converter. It will also do the job. It will also do the job. So the rectifying diode was used to power this charging system. You can see this was gotten from a computer supply. This is a computer supply. You can see it. This is a computer supply. It was gotten from central processing unit. Central processing unit. So I took the fan, I took the housing, I took parts of there's some things like transformers so I connected them together to be able to charge the system. You can see how it's working. Don't worry guys, I know you guys would have loved to see this thing working, but right now I don't have any battery with me. The one I have is bad, so I'm getting a new battery which we'll be using to test the system. Like I said, we're having a delay of around 10 seconds anytime we try to use this 1 horsepower to power this electric motor. So that is to tell you that the electric motor is a little bit downsized for this 2900 watts alternator. This one is bigger, so we obviously need a bigger DC motor to be able to spin this one to produce electricity. One thing you guys need to take note is that the RPM for this needs to be around 3000 RPM or 3500 RPM. To spin this to maximum is 3500 RPM. So the RPM of the DC motor needs to be put into consideration. If your DC motor it's producing up to like 2500 RPM, this alternator and this one right here would not produce electricity. That is one thing you need to take into consideration. Make sure the DC motor you're getting should have the speed should be around 3000 RPM or at least even higher, 3500 RPM, to be able to spin this very well. So be using this one to spin this one so that this one can produce instant power. So what I wanted to do was to start large, use this big alternator with this, use a bigger motor to be able to power this, generate power from it and be able to use it. But I noticed something. It is best to start slowly, start smaller. You start scaling up the system. First, you start with once you start producing power, you start from 100 watts. of power. From there, you start scaling the system. You need to notice that this project is very sensitive in a way. Whenever the system is working and there's a load being connected to it, let's say for example we are connecting an 100-watt bulb to this system, it will definitely affect the speed of this DC motor, which means the speed is going to reduce. Why? Because it has sense, it has take note that it has sensed, it has taken note from the alternator that there's a current, that a load is being connected to the system, and once it senses that there's a load being connected to the system, it will reduce the RPM of this DC motor. Reducing the RPM of this DC motor means it will be consuming more amps. Remember, we need 62 amps to power this DC motor. So once you connect an 100-watt bulb, we are consuming more amperage from this DC motor. So for us to compensate, you need to make sure your rate of charging the battery, which will be powering the system, should be faster or should be greater than the rate of discharge. That is the only way it would work. So guys, thank you so much for joining into my live. I'm going to be showing you the progress of how the system is working. Though I could have, how I wish these wires right here are 6, which will be for the rectifying diode, for the AC power, and for the capacitor, but I'm going to make do with what I have right here, the capacitor and this AC line, which is for the output for the 220 volts. So this is perfect for me. So guys, thank you so much. Let's just go around so you guys can see everything. You can see this is the wooden frame. I don't want to use this wooden frame anymore, so I'm going to be moving it to an iron frame, a generator frame, so that everything should look professional as it can, and it's going to look rigid, nice. This DC motor, some of you might be thinking where to get a DC motor. This one was gotten from a vehicle, from a car radiator fan. It's big, the camera is not doing justice. It's bigger than it looks on camera, and it's very solid. Most of them, you will see them rating Bosch on them. Those are very high quality DC motor. Like this one is high quality DC motor, very solid. Very solid. They can work for a longer time. Why I went for this, though your application might be different, why I went for this DC motor is because this one are used for car radiator fans, and once it's in the vehicle, those fans do run all the time. So this one will work very well for me. Some people do go for a different types of DC motor. You can go for a 24 volt DC motor if you want. The 24 volts DC motor will use less amp but more voltage. That's one thing you need to know. It will use less amperage, but it will use lesser the amp of this. It will use lesser amp but higher voltage to be able to power this. So you can go for 24 volt system. I don't want to go for a 24 volt setup. If it's for an inverter, I would tell you to go for a 24 volt system. So this is the one we're going to be using. It looks old, but it's working. Like it's working. It's working. A while ago, I tested this. What I did was to quickly connect this one to the shaft of this. I've already started working on the pulley. I didn't bring it right here. There's a pulley, there's something, you can see this threading right here. There's a bolt that will go, a nut that will go around it. And I created a plate from a old gear system that once you put it right here, it has 2 screws left and right, so that we'll be able to connect a smaller, the work of it is to help the imperfection of these two. Like these two are not aligned. If you can look at it closely, you will see this one is slightly to the left, this one is slight to the right. Because of the imperfection, because of they are not aligned, the misalignment, I'm using this leather. So what this leather does is to reduce the misalignment will not affect the process, or it will not affect the function, the operation of the system while it's rotating. So everything will be you will just notice this leather will take in most of the misalignments because it is flexible. That's one way I will recommend this. I've seen some people use what is it called? Use leather on these guys, like use fan belt. Fan belt is also good, but I would not recommend you using a fan belt to from this one to this one, because the most times, in most cases, the belt do slip will be reduced. The efficiency is not 100%, but using this direct coupling will help to be able to spin this alternator the way it's supposed to be. It will be able to spin it with maximum power. There will be nothing called slip. It will not slip while rotating. It will be able to spin it directly, and there we should be able to have up to like 95 to 90% efficiency in spinning the alternator. We don't want it to be slipping, because using a fan belt, it means over time you need to change the fan belt because it's going to wear out. But with this, you don't need to change anything. It's going to keep on working like this, and it's hard for you to see them fail. It's hard for you to see them fail, and it's easy to remove. You can say I use the bolt right here to hold it. Once you remove this, you can remove this belt, and you can change it. And this belt is very thick, so it's not going to get bad anytime soon. So I recommend using this kind of coupling. A direct coupling is better for this kind of setup, because you need to be able to spin this. You don't want it to be slippery. So guys, thank you so much for tuning in. I don't know if I should maintain this. It depends on the kind of battery I'm going for. You can see this was gotten from, I think I got this from a Mercedes 200 battery terminal. Yes, this terminal was gotten from a Mercedes 200 vehicle. You can see how thick the cable is. I make sure the cable are very thick based on the amperage that the DC motor will be taking. One thing you need to consider is that whenever you're dealing with a 12 volt setup, be it a fuelless generator or an inverter setup, you need to know that 12 volts do consume a lot of amperage. So it is best to use thicker wires to be able to handle that amperage from the system, because when you use smaller wires, most times they get hot, and they might even end up getting burnt in the process. Some do catch fire. I've seen some of them do catch fire because the amperage, the wires will start heating up because of the too much amperage from the system. So you can see this one, though it was gotten from a Benz 200 model. You can see, I think Benz 200. Yes, Benz 200. That's the old model. You can see how thick the wires are. I don't know how many gauge these wires are, but you can see, I don't know if you can see the logo. The logo is there. You can see how thick it is. The thicker the wire, the more amperage it will be able to handle, which is better. So I don't know if I might end up maintaining this. It depends on the battery setup we'll be going for. If it's using this, or if it's using the different types of setup, we'll go for it. So guys, there you go. You can see it. This is the smaller one we'll be using. We'll be using this smaller one for our setup. This 1000 watts alternator, that's what we'll be going for. Since this one we are having a little bit of delay, getting a bigger DC motor for this would be perfect. It will be perfect. You can see it. It's just that one thing I will tell you is that most of them, for the bigger alternator and the smaller alternator, they're almost the same. They both come with three different outputs. You have the line going for your rectifying diode, which converts to DC currents, which you can use to charge. Most people do use it to charge car battery, but though it's 8 amp and it will not charge efficiently as it's supposed to. And we have your AC line right here. This is where we have our capacitor connected to it. I advise use a 30 UF 30 microfarad capacitor for this. It will work very well. Yeah, it will work very well for this one. So that's just what you need for this one to keep functioning, a capacitor, and it will output the output voltage for this. So this was using originally, let me tell you something that I almost forgot. Originally we were using this alternator comes with, it doesn't come with capacitor. It comes with AVR, which is automatic volt regulation. Automatic volt regulator. So what the automatic volt regulator does is whenever whenever there's a load being connected to the system or is being connected to this alternator, the engine can feel it that there is an heavy load that is being connected to the to the alternator. So practically, the generator RPM will be reduced. So because of the load that is being connected to this alternator, let's say for example you're connecting a pumping machine. A pumping machine, some of them are around, the starting power is around 1,000 watts, some of them, because electric motor do use times 2 of their power to start. So whenever you connect a pumping machine or a pressing iron to this alternator, it's going to affect the operation of the engine. So the engine is going to reduce. Whenever the engine reduces, the AVR, which is the automatic volt regulator, it is connected somewhere here. What it does is to send signal to the engine that you need to increase the power of the generator. What it does is to take in more fuel from the carburetor, speed up increase the RPM of the generator so as to be able to handle that load effectively. But Tiger gens, like the smaller one, I Pass Your Neighbor, they don't do that. Whenever you plug a load to them, they reduce it. Why? Because they don't have automatic volt regulator. What you need is to manually increase them. But this one, the automatic volt regulator does the work to increase the power so as to accommodate the load that is being connected to this. So what I did was that I was using an automatic volt regulator for this, but I noticed that since we're using a DC motor to spin this alternator, we were not having the voltage required. We were having around 100 volts to 110 volts. So I converted it into a capacitor of 30 microfarad. So I was able to have an output of 220 volts to 250 volts. So you can see with a capacitor, I was able to increase the output of the system. So I'm thinking of using a DC to DC converter for the charging system, but the amperage needs to be put into consideration also. That is one thing we need to consider. That's one thing we need to consider. So you can see this one doesn't have much wirings like the other one. This one is just basically a capacitor. It doesn't use AVR, which is our automatic volt regulator. So guys, thank you guys for tuning in. Thank you guys for staying in to this time. I really appreciate it. Can see the fun. It is always best to, one thing I want is that I always like efficiency. That's why this fan is connected to the charging system. So this fan helps in cooling the system. You know, whenever a system is running, a system is running cool, it will run efficiently. So it is best to put fans to these things so that they can work efficiently as possible, because once they're running cool, they run efficiently. When they are running hot, the efficiency would not be there. and that would not be good. Sometimes they can end up overheating. Yeah, they can end up overheating. So guys, this is how it is. I just want you guys to see it for the last time before we start our new project. Maybe by tomorrow I'll be shooting the first stage of the new project with this alternator. So today I'm going to go get some parts for the first phase, which is for this alternator. I'm going to get the first phase. Yeah, this is our terminal. You can see how thick and big the wiring is, which is cool. For the amperage, remember, you can see the PC fan for the charging system. So I just want you guys to see it for the last time. You're going to see more transformation. This one is using a wooden frame. We're not going to use a wooden frame. So one thing was that I didn't want, I wanted to start the project badly. And since I wanted to start the project badly, to get a frame to start the generator was a challenge. That's why I decided to use this wooden frame you are seeing right here. The wooden frame was to speed up the process of the project. Because getting a frame, you have to talk to the welder. You have to discuss with him measurements, precision, how the alternator is going to be placed. And even this flywheel you are seeing right here, I had to do serious work on it because I had to cut the shaft that will go through this what is it called? The flywheel and the alternator are totally different. So what I did was that the engine shaft would work with this flywheel. So what I did was to cut off the engine shafts, went to the welder, and I took the shaft from the alternator, connected it together. It wasn't easy to align them. Take it to a welder and they were able to join them together. And I was so surprised. Okay, no, I took it to a panel beater, so they were able to get it straight. So you can see it's rolling straight. It's rolling straight. I'm still going to be using this setup later on in the future with a bigger motor, maybe a 24 volt system, a 24 volt motor I'll be using to power this one. So it's going to be powerful. But for now, we're starting with a smaller setup. We're going to be using the LMAX. You guys know it as LMAX or Fireman body frame. We're going to be mounting this one on it. We're going to be mounting this one on it, mount this 1 horsepower DC motor, so that everything would work as the way we want it to be. So once we've succeeded in mounting this, I'm thinking of using this mount. You can see I've been doing some brainstorming. You can see we have some holes here for our screws, though this one doesn't come with threading. This two doesn't come with threading, so I'm going to find a way we can put a bolt and put a nut behind it so that it would be able to hold it in place to the frame. So I just want to find a way that the only thing I'll be mounting there that will need to take it for welding should be maybe where this place will be sitting down. Yeah, this place. I'm going to be using this side for the sitting. For the sitting of the new generator, I'm going to be using this side. This side will be great for the sitting. And so it's going to be sitting upside down. We're going to make sure it's sitting upside down. So we're going to put it upside down so that these two mouths here will be, these two holes right here, that's where the two screws will be passing through. Yeah, these alternators are very heavy. Even this one right here, I don't know how many pounds it weighs, but it's very, very heavy. Like anytime I try to lift it up, I feel the weight on my back. So guys, thank you guys for watching. Thank you guys for tuning in. I really appreciate. So I'll be ending today's live stream here. I'll be heading to the live stream here. You guys are awesome. Love you guys. And take care. I'll be seeing you guys on the next video. The next video should be starting with a new project. Thank you guys. Love you guys so much. Take care.